didn't have to break the glass, didn't have to jimmy the door, didn't have to steal the key, didn't have the key, didn't have the knob, but when you get to the car open. How is that? All right, Jose. We have been talking about doing something like this for a while. We used to have long conversations on my way to work and like 45 minutes conversation about architecture, code, software, legacy, and everything else. And we have been discussing about coming back to those discussions. I think that keep us up to date, and it's kind of a way to do this architecture autopsies of we have seen and we have developed hundreds of this system. So why not going back one, recall it again, remember,
Mhm.
relive it, and two, get the main points, get the best practice, get what we learn. And today we'll be discussing Bluetooth. As you know, I have spent several months working on Bluetooth back and forward. It has been a roller coaster to say the least, but
Mhm.
definitely I have a lot of learnings from it. So I want to kick off, Oche, first one with a story. Like,
Mhm.
as you know, all the modern cars today, they most of them, like before we used to have a key that we just put in the car and turn the car on and go away. After a while, we had like a key fob that they recognize that it was you. You open the car and then you just push a button, the car turns on and drive. And now even the phone. So if you see all these new electric cars, you have your phone, you get close to it by proximity, it knows it's you, the car's open. I work a lot in Bluetooth, and when I read this research, it really catch me off guard. So the goal here is someone called walk to the car, didn't have to break the glass, didn't have to jimmy the door, didn't have to steal the key, didn't have the key, didn't have the knob, but when you get to the car open. How is that?
Well, like the first thing that you can think about is that the car was not well closed or the key was stolen. Because to be honest, it's like I'm kind of old-fashioned in the sense that all my logs in my home are like normal logs, like physical logs. And I've been thinking about getting like a something like this smart lock, like with Bluetooth, because I don't like to carry stuff. But I usually think that well, physical logs they do have some problems, but then once you make them smart, you include all the possible problems that you can have in software development. So I guess there is a lot of things to. I don't know if you will make it safer or not, but also since I kind of for a while play like with electronics, trying to make my own electronics, I know how hard like hardware can be. It's not my thing. When you do software, you click, you have the click handler, you click twice, it's two clicks. In like electronics, it's not like that. So tell me a little bit more about the story.
So the car was locked completely. No
Hmm.
door was open, and the key of the car was on the owner's pocket, miles away from the car. So what is interesting there is that, and we'll come back to the actual implementation and the story, is that they were able to relay that Bluetooth signal from miles
Hmm.
away, and it could have been from one state to another state. So
Hmm.
imagine how far away.
Well,
No,
from country to country, Javier.
yeah,
From country to country,
exactly.
because there is
Exactly.
no
So they
this
were able
internet.
to relay that Bluetooth signal from one transmitter to one receiver and trick the car into thinking that the owner was right next to it. So by proximity, the car opened, but it just needed, and this is the part that it really blows my mind, a cheap hardware that gets the Bluetooth connection relayed some way, somehow through Wi-Fi, through cellular, through radio frequency if it's close by, to the receiver, and the receiver to the car. And that was able
Yeah,
to
that's
go.
a big distance, a big
Yeah.
distance. But again, as I say, like internet is distance zero, right? So
So we'll come
Okay,
back to that
so
one because I spent,
they relay the key information from one state to another state where the car was sitting, as I understand.
yes, they relate
Mhm.
the proximity that the owner was right next to the car. So even, and we'll come back to it, even if they add, and this is the part like I spend a lot of time doing this, even if they are encryption to it, so a challenge answer question response, they were able to trick the car and actually reply exactly with the answer that the car needed because at the end they was sending the information that the car was uh, transmitting to the key and from the
Mhm.
key to the car back and forward with two chip hardware
So,
devices.
so basically like a proxy, like
Exactly,
I
exactly.
get the
As a pro.
signal and forward it, and then I get the response and forward it, and then you do the whole loop.
And that work on Tesla, that work on other EVs, that work in a lot of cars that have that technology. And we'll come back on what was the actual fix. And we'll come back to
Mhm.
an interesting story about an actual fix being in the car and not being used. So that happens a
Mhm.
lot, that you have the capabilities to make something more robust, but then you still, by convenience, by making things easier, don't use it. So before moving forward, Jose, I have also three other things that I wanted to discuss that really ties together what discussing today about trust,
Mhm.
security, and things that were built right, but still were not using how they should have been used. So the first one is I'm reading here about a security incident that a security firm called Sysdig disclosed what they believe to be the first fully autonomous ransomware. Basically, someone got into a server through a bug on a tool called Langflow, and they
Mhm.
deployed AI agent. And what is interesting about it is that AI agent was able to do everything: the snooping, the finding the credentials, the encrypting the database, and even when the server returned data that was not supposed to be in the right format, it returned XML instead of JSON. The AI agent adapted, changed their script, parsed the response, and in 30 seconds was back doing things. So
Mhm.
it's able to adapt to what is finding. It's not like a fixed script that, hey, find me this. No, it's able to see, I'm not getting what I need. What do I need to change?
Well, to be honest, I think that all these things were actually possible before. There is kind of nothing new there. The thing that is new, I think, is the speed. Before you cannot, I mean, you will have to take a look to the XML, see what is wrong, and at that moment, the car is gone. I mean, someone drove it away. It's been a week, so now that loop is extremely fast, right? Because the AI can get the information, the agent, and immediately figure out this is not the right format, right? So I think that the vulnerability was there since before. I mean, in a
Yeah,
lot of
but
cases.
what I do believe that is interesting is that it lowers the barrier of the hacker. The hacker didn't
Yeah.
need to
Yes.
do the whole script. He just need to know how to get in there, deploy the agent, and let it work. And he was able to
Yes.
do all of those fully autonomous, encrypt the database, and do the ransomware by itself. So it's a next level attack. And
Yes.
and that ties in DigiCert, the company
Mhm.
that we always use for signing all our apps with the dongle, and it runs a survey in more than 1,000 IT companies, and like from those 78% already have AI security related incident. And what is more concerning is more than half doesn't even have any security response for the AI and cannot even track which model did what happened, what did they do, what they access. They can only try to remediate after the issue. So
Mhm.
I do believe that security is always a huge issue, but it's going to become more and more something to be aware of.
To be honest, I think it's going to be more, like before, like when I was in university. That will make me sound old, but no one had laptops. I had a laptop because I work on an IT company. So you just didn't have the access to the stuff. Now, basically, you can go like to AliExpress, you can buy electronics there, get the dongle that you want, read some articles on the internet, and basically every person can do that. And like, like teenagers that are like figuring out the stuff, misbehaving sometimes, they can do even like without intention an attack that is a level of a high level attack, as you say, like something that one country can do to another country, for example, and just by giving it a try. I mean, it's so easy to make a big mistake if you cannot handle the stuff like agents. And it's also really easy to make mistakes in leaving door open if you don't write the code or you don't know about the security standards. So I think that, as you say, like in this new era of AI, uh, that is something that it will be in every person's mind. I mean, as viruses for Windows computers became a thing that people have to buy antivirus, now you have to buy something like a security agent to be checking
every time.
stuff. Mhm.
So, and just to end up this security section, there was another story for 2022 where just uh, a guy sent invoices to Google and Facebook just from the email address of a known vendor that they used to use for hardware bills, and he was able to get paid more than $100 million from Google and Facebook together. And just because they relate the relationship, nobody even think twice on paying those invoices. So sometimes the attack is more about social engineering, about relaying a trust, than actually being really technical. It's just how can we see what this system trusts, what this company trusts, and use it against them. So uh, really, really interesting there, the way in that AI and actually the hackers sometimes are able to get these things, make these things happen. So, but Jose, how do we get AI to even do that? If you see now a lot of AI models are being guarded against this type of attacks, and when you try to do something, you say, "Hey, can you decompile?" It right away it warns them or it flags them as, "Hey, you cannot do that because that's against the security principles."
Mhm.
So how do you think people are getting around that?
To be honest, I think that you do it by distillation. So you get a big model like these 200 billion parameters or things like that, and then you do a distillation of that, and you make a kind of a clone, and you can basically rewrite the security rules. So what's happening right now is like, okay, before you have the big players, OpenAI, Anthropic, Google, that is more or less there. And I mean, they have a lot of people in their team, like for security, for like psychological things of the model and so on. But the main problem is that this is a powerful tool, really a powerful tool. I mean, if you have an axe, you can use it to chop trees and make a house or to destroy a house. So this goes like the same way around, right? So I think that the problem with having no control over the open weight models is that you can have distillation. Even from the big models, you can have distillation and you can make a model that is as smart, as fast, but not with the same security rules. So that's totally possible at the moment. It takes time. I mean, it takes time, but you don't have to be the person who do the distillation over the model. I mean, you can just use something that was distilled by someone else, right?
I also believe, Hoche, that for the models that right now are presenting that those warning, a lot of time is as simple as telling them, I work for a cybersecurity company and we're doing this ethical hacking or we're doing this project or we're doing this investigation, this
Mhm.
research. And the model, there is no way that he knows that what you're saying is not the right and he actually goes along with it. Only by doing that, you can see that a lot of models let you bypass that regulation. And the other part is using a model that doesn't have those safeguards. There are a lot of open source model and a lot of models that you can download now that they won't even blink when you ask them to do this type of things.
Yeah, no, and it's also like, like once you make something, I mean, whatever thing that you make in general, once it's in the market, I mean, if you really wanted to do something and the product is in the market, you can basically take any electronic and reverse engineer it. And the only protection that you will have at one moment is the law that it was patented for you and it's forbidden to do it, right? But that there is a technical challenge to do all this reverse engineering. There is, like, it's not low, but it's not impossible. So you can bypass those rules kind of
And it's getting
with a
easier.
little bit of effort, with a little bit of effort, let's say it like that.
All right. So now let's talk about the Bluetooth because definitely I have some love-hate relationship with the Bluetooth, and I'm basically uh, talking not about the connect my headphones Bluetooth, but about BLE, a Bluetooth Low Energy. And you can see that that now is everywhere now. You see it on fitness trackers, on door locks, on medical devices, in your car key, like what we were discussing. And
Mhm.
if you actually take one of those sniffing tools to see the Bluetooth everywhere, you'll see that anywhere you are, like you will like your screen is full of Bluetooth devices everywhere and you don't even know it. If those wave signal will have color, you will see around the air like a huge rainbow.
Yeah.
It's crazy.
Yeah, I always wonder like how many signals are going through our bodies and through the plants and through the stuff that you have at home. Because I did like one experiment like last week. I get a Raspberry Pi and I make a VPN for my home so I can connect from when I'm outside and connect to all my devices like the computers. I have a lot of computers here and to SSH through them and so on. And like I asked the AI to do the to set up the Pi for me, the Raspberry Pi. And well, it did a normal setup. It was working at the beginning. In that same evening, I was really happy because the VPN was working. I said like, okay, like I cannot say it right now because I'm in my living room and the lights will turn off or on. But I say something like Alexa, like lights on, and nothing work. Why? Because something on the Raspberry Pi was transmitting in the same frequency that the smart plugs uses. So by doing that VPN, I basically mess up all my smart home things. And I thought like, I have so many lamps. I have to turn it off manually. I need to fix this. So yes, there are more things going on that we think that they are going on. To be honest, I never thought that that will happen, but it did happen. Like
I don't know.
the
That
Raspberry
is
Pi was messing with my network.
I think that the amount of devices is on the billions of now.
Yeah, of
It's,
course.
it's crazy. And if you think about the name Bluetooth Low Energy is about saving energy. So instead of a Bluetooth like connect your headphones that you make a call, it's like passing a note, passing a post-it. Instead of talking with each other, you just only pass little amount of data. You say, hey, this is my sticky note. And you read it and send me back your message. So that's how it works. But as you know, Jose, we have done our fair amount of development over sockets. And
Mhm.
basically, right there is just it work or it clearly doesn't work. But with Bluetooth, it's different. With Bluetooth, you know for sure that the nature of the BLE is unreliable. So, meaning that you have to design your system for failure because that radio has, as we were talking about,
Mhm.
they have interference everywhere. There is the walls, the distance, the trees, reflection. If you have paper, metallic paper, it reflects.
Mhm.
If you have a lot of walls, if you are in a basement, it gets the
If
signal.
you have other things, right, that are
Exactly.
broadcasting or
As your
something,
example, they can
yeah.
collide with other things. Is crazy. You have to design your system knowing that it has to fail, and then you have to recover gracefully. There is another thing. Android and Apple, they that operating system, they don't behave nothing alike. One works one way, the other one works a completely different way. So
Mhm.
I will tell you a story about Android specifically. Let's start with that
Mhm.
one on Bluetooth. There is an error on Android. I will say the main villain. This called Android error 133. Do you want to know what that is, Coach?
No.
It's not exactly. You should know.
Yeah.
You should not want to know. It's just una specific error. There is no explanation at all
Mhm.
of what is the 133 error. And the only thing that you can do is just reconnect back again. And hopefully it doesn't happen again. And That one is one that I still don't understand why Android cannot give us like a meaningful message. It's just basically no something on the Bluetooth style fell off, just stand up again and do your thing. But we don't have another explanation for that. So that one definitely we need to plan for it. We need to actually, if
Mhm.
it happens more than once, give some timing for the gut to recover and give some recovery procedure. And there is no way around it. Now and then you will have that on Android, you recover, you come back. The user doesn't need to know it. You do all of that in the background, but it's definitely annoying.
Well,
So
like, yeah, like, there is, I don't know who say this, but it's a famous person, I guess, that I had it in my blog as a tagline for a really long time that really advanced technology should work like magic. You surely don't know, um, you don't know, you should not even think about how it works because, man, I always like the most complicated things, like doing the Linux stuff, downloading the drivers, editing the files, and so on. And well, I think it was you who told me like about the AirPods, and you told me like once you have them, it's like they work so seamlessly with your iPhone that you will not even think about it. You will just enjoy it, like to put them and they will be connected. You don't have to pair them. And I used to have like these like expensive like wire headphones, and for me it was the most beautiful thing. And then I understood, man, I'm in the past. I need to use AirPods because they work like magic, right? You just like open them and they are there, right? So,
they
so
work really good, and especially in the Apple ecosystem. If you switch to a Mac, they right away detect that you are in a
yeah, I mean, all of that is like magic, and I think that underneath that magic there is a lot of if statements, if
yeah.
else, and so on. If else, retry, and looping.
No, it's crazy the amount of things. So in Android, for example, the 133 is the non it's a faceless error. It's basically
Mhm.
like Game of Thrones. I have no face, you don't know who I am, just there is no way around it. You just when that happens randomly, you just breathe, give it a second, reconnect, you're back again. But then you also have connections timeout, you have authentication failed, you have connection failed to establish, you have dropping connections, you have a device unreachable, like is a pairing state mismatch if there
Mhm.
is something that one of the devices forgot about the other one after pairing. So you have to be handling one by one all of those errors so the user doesn't even see what's going on. But if you log it, it's like crazy that this is working, that this is failing.
Yeah,
So
to be honest, that's what um, I was thinking that first there is a lot of things going underneath, and all the code that you're mentioning is not even the logic of your app. It's not the business case that you're like solving. It's just like connecting to the electricity outlet, in the wall. So,
and let me say something else that you will
mhm.
you will really get a kick out of it. What do you think, Jose, when you have several devices competing through Bluetooth for a connection, or when you are sending several Bluetooth commands, or when you are discovering at the same time, when you have all of that, if you remember everything that we have experience on multi-threading and so on, you know for sure you're gonna get a race connection. Though
Yes, right condition. Yeah.
they are gonna bump into each other, they are gonna disconnect the device, they are gonna put a device in a state that is not the right one. You will have to clear the cache of the card. You will have to redo everything again. So you need to put everything in a queue. You have to have a state
Mhm.
machine that handles everything that
Mhm.
is coming, that they lock each other out for just a little bit really fast, and then you can continue your management. Or you will have like a really bad user experience. Also, there are things like I was mentioning difference between Android and iOS. There is a in iOS, it handles the connection, the transmission together. In Android,
Mhm.
you have to basically uh, negotiate what will be the MTU that they are going to
Mhm.
communicate between each other. iOS handle that automatically. Android, you need to take care of it. So you see the amount of detail that you have to go in each of the platform, that is crazy, that you are able to make this really reliable. But as always, that's our task, that's our job, and that's how we do it.
And like I guess if you have like a different type of device, for example, let's say like a computer that you have a different OS, you will have to handle it different too. So again, you have like as I told you before, like okay, you told me a lot of like things that you need to handle. That's boilerplate code that is not even your business problem that you're fixing. And then you have to do it twice because you have to do it for Android and for iOS and for whatever other OS that your device is supporting. There are billions of Linux flavors. If you happen to do something for one of those, then I guess you have some other cases, right?
No, and you also have to deal with what I was mentioning, the payload. What is the transmission unit that you are sending? How much data are you sending? Are you sending too much? Are you drowning the device? You also have to handle when you are trying to do pairing. What if the user cancel the pairing and doesn't allow you to move forward? You have to redirect into the right place. So there are a lot of things to actually make this work and make this work reliable. But
Mhm.
as always, nothing that is easy really give you the satisfaction to have a system that like makes you learn and makes you
Mhm.
put all of this learning into place, and then you see that it is behaving as it should. Of course, logging is huge here. You need to always try to have a huge logging procedure because you will definitely find edge cases that you will be need to keep handling. So after we did all of that and everything is working as it should, then we have the questions. I put all my effort. I have the solution working right. It's encrypted. My data is protected. Then why did they open my car?
Well, like for now, I cannot see where the breaking point it will be. Maybe they broke your window or something like that.
No, no, they didn't. They didn't. As we mentioned in the beginning,
No,
they
the car was intact. The
walk to
car
the
was
car,
intact.
they walk to the car open. They are able to drive away if they want to. So, like, if you think that even some cars now have a pin feature, that even if you open the car to drive, you can request a pin. I don't think no one uses that. The other solution that I have here about that is put your key in a Faraday cage. So imagine, Jose, that you have to put your key or something in a Faraday cage so it doesn't go away, doesn't
Well,
emit.
like
So that's not user friendly. Let's say that.
yeah, no, yeah,
That's
no,
for
like
people that are paranoid. But again, that's a solution. So the idea here, as we mentioned, is they use two chip radios. And actually,
mhm,
they can even use two chip phones, one
mhm,
next to the key, one next to the car. The car tries to communicate, we relay the information that we're passing through Bluetooth.
mhm,
We'll say, okay, why not we do encryption? We do a challenge text and answer. Only we have the key. So there is
mhm,
no way. But we are not doing anything like passing the information. We're just a relay. We're just a proxy.
mhm,
Still is going to reply correctly. Still, you will
mhm,
be able to open the car. So that was a really interesting research. And for me, the weakness there is you should not use that for proximity sensor because it will get hacked. They will find like it's really fast the way that you can relay information through the internet. So what they come out with is instead of using that one, there is a new radio. Let me try to find the name that is called ultra wideband UWB. That one
mhm,
also measures the time that the response should have arrived. And if you are really close to the car, the time is instance. So they can actually measure. And just with that one, not with the Bluetooth is not fast enough. Just with that one, they are able to put a UWB chip in it and relay it. And that supposedly fixed the issue. Now, what happened with Tesla? Tesla put that chip on the car but was still authenticating the proximity with the BLE. So
mhm.
it was there, they have the capability, but even if the advertising was there, some research group I think that is called NCC group. Let me look at the article for just a second.
But like while you search that,
Yeah, NCC group.
um,
They were able to do the link layer relay attack.
yeah, but what I'm trying to say is that in general, like as a program, well, like you have a few problems here. You have the technical problem and you have the user experience problem because I guess to have the proximity sensor, I mean, or the proximity functionality is kind of really, really nice, but it's not secure. So you always have a trade-off, right, of how secure the stuff are
Exactly.
and the user experience. I mean, you can make it really, really secure in the way that it will be so inconvenient that okay, only with the correct key, right? But then then the feature that you're developing is worthless, I think, because it's like if the user complains about what you're developing, so you need to balance all the user expectations, the company expectations, and the security expectations too. I guess that like you have to find the sweet spot and that seems complicated.
Yeah, but if you think about this, Oye, they tried to fix this. They tried to use the signal strength, the RSSI, and with that signal strength, try to approximate the distance and say, okay, the round trip through Bluetooth should not be the same distance, the same time as the Wi-Fi like relay attack, but they are really fast nowadays.
Mhm.
So that was not completely accurate, and they were able to break it either way. The only solution was to actually use the UWP chip, the UWP chip that definitely, instead of guessing it from the RSSI strength, you have a way to actually measure the distance, and that's basically the way that they were able to fix this. Instead of guessing from the signal strength, they measure it directly. And and for me, it's like again, as you're saying, I was watching a security video like 2 days ago, and they were saying all the Wi-Fi WPA2 are unsecure because if with enough time they can break it. But you know, you know that that's a possibility. But it's like driving a car. You know that you can crash a car, but you accept the risk, and what you do is you put the seat belt on. You try to the best thing in this case, like in the Wi-Fi, just put a huge password. It will take a long time for that
Mhm.
for them to break it to any characters password instead of a
Yeah, to brute force it.
yeah. So that what tells us is that sometimes everything is right. It's just the business use was not the right one for the Bluetooth. They were able to break that, and the solution was actually going away from that one to a different chip that actually give you a more accurate proximity sensor. And I'm pretty sure, Jose, just by reading at this, there have to be a lot of code out there that this attack still applies. So is that's the
Yeah,
word.
no, yeah, and like because like who reads those things? I mean, the security news. That's why we're making this episode actually, and is well, you have some vulnerabilities, and I think those were there before. It's not something new. Everything will have it. Every time of new technology, every time of current technology will have it too. But now with AI, the speed that you can have while you're trying to break those things is way faster. So now we need to rethink about security in a different way. Also, electronics have become really cheap and common. You can go to any this like I love Arduinos, I love all this stuff, and I used to love to browse all the components that you can put in a Raspberry Pi in an Arduino. You can have all type of Wi-Fi receptors, Bluetooth receptors, and so on, right? So the the surface that you will have, the attacking surface, is really big, way bigger than you think. Because in this we can include, I know that it's like going too far away, but this you can include the vulnerabilities of the security system. Sorry, of the operative system. That what will happen if someone break the the encryption, how they work on Androids, how they work on iPhones, or things like that. So the exposed surface that you have for an attack is way bigger.
No. if we come back to the Bluetooth implementation, what are our conclusions there? The first one, definitely defensive programming. You have to assume everything will fail and handle that gracefully. The second one, you need to
Mhm.
be aware of your platform. Android, iOS, any other target will have huge difference. You have to do your state management, meaning you have to handle your connections so you don't have to try to reconnect every time. You have to also keep alive those connections. You have to basically do a service discovery state as
Mhm.
clean as possible. The last one will be security, that for me is one of the best one. Basically implement encryption properly. Or
Mhm.
you will have the issue that someone could even get a hold and basically command your device to do anything they want if they're able to. As you can see, a lot of devices have their GAT open that you can go basically iterate through the services, iterate to the characteristics, and start
Mhm.
making assumptions what they do and how they do it. And of course, like basically all the pairing, what is the management of the first time pairing, return pairing device, multiple devices connecting at the same time. I like also to put some logging in place for detecting all those race conditions, the concurrent access. Remember, everything has an effect. If the device is out of range, if the battery is dead, if there is concurrent access, if there is parent cancellation, if the user toggle their Bluetooth off on their phone, if there are encryption failures, all of those edge cases you have to take it into place. And
Mhm.
the best system in the Bluetooth world is the one that anticipate all those failures. Oche, thank you for that conversation. I'm really looking forward, Jose, to the conversation that we have planned about how do we deal with huge amount of data, a huge
Mhm.
amount of photo, a huge amount of videos. How do we basically implement a new Instagram, a new Messenger, a new heavy image related application? Looking forward to that explanation from you, Jose. Thanks
Mhm.
everyone for being here and see you in the next one.
See you.